unless there is something truly valuable to extract from them, to go ahead and bury them or incinerate them. Incineration technology has achieved an enormous advance in the last few years. It is possible to burn anything, really anything, without emissions that cause any kind of problem whatsoever. But to repeat, we should be responsible for what we do and for any kind of problems that we rise. None of this is in dispute. But the question that can be asked, recycling aside, taking the environment as a whole, we can ask, how clean is clean enough? How much of our economic resources can be devoted to the environment when there are other issues? For example, education, housing, health issues, public safety, roads, transportation. All these things also have a call on the very same tax dollars. Now, these are not easy questions to resolve, but my position is that after 20 years of putting the environment first at the very highest priority, it is time now to take a look at it, find out what have we accomplished, how much has it cost, and is it worth it? That last question, of course, is almost heresy to ask. Well, let's begin where the real environmentalist actions started, with the 1970 Clean Air Act. At that time, there's no doubt, but what a lot of emissions of what we can identify as pollutants were being poured into the air. Since that time, according to the Environmental Protection Agency, 90% of all of the identifiable pollutants that used to pour from our factories and chimneys and municipal facilities of all kinds, automobiles, everything, 90% have been removed. Some people say that's not enough, but removing 90%, that's the good news. The bad news is that it has cost our economy $1.4 trillion. And that is a lot of money. As I say, some say that's not good enough. We should remove 95% of all the pollutants. That additional 5% is calculated, if we move in that direction, to cost an additional $1.6 trillion. Is it worth it? Remember also that these pollutants include such things as sulfur oxides, nitrogen oxides, volatile organic compounds, carbon monoxide, ozone, and so on. And all of these substances are produced by nature as well as by human activity. And we're down at the present time to trying to control amounts that are very close to the amount that nature is producing anyhow. And there's no way we're going to stop nature from producing sulfates and nitrates and ozone and all of the rest. We are controlling these amounts now in amounts of parts per billion. Now, it sounds easy to say a part per billion. You know, it's a little bit. How little? Well, it's tiny. How tiny? Itty bitty. How can we get a mental picture of how small 1 part per billion is? Only by, I think, making an analogy. 1 part per billion is equivalent to 1 drop of vermouth in 5 carloads of gin. But that's a rather dry martini, you know? Yeah. But we do and are controlling effluents to not just parts per billion, but in some instances parts per trillion. And that's equivalent to 1 drop of vermouth in 5,000 carloads of gin. Are we going too far? Because there's no way we can have total purity. In fact, it is claimed that with the new Clean Water Act, whose requirements are just going to be going into effect later this year, if we stick by the letter of the law, there is nothing that can be put into the waters of the United States except distilled water. Because everything else is a pollutant, and so defined under law. Are we going too far? Well, still talking about clean air. In 1980, The Congress, a few of the members of the Congress, became concerned about some of the charges that were being made, particularly with respect to that awful thing referred to as acid rain. It's a very pejorative term. Acid rain, by its very term, it must be bad stuff. Never stop to point out that rain is always acid and always will be, because the water that falls from the sky passes through the air, and the air contains carbon dioxide, and some of it dissolves in the water, and that makes carbonic acid, and therefore rain is always acid. However, it was claimed that acid was added to the air through the effluence, particularly of utilities burning coal in the Ohio Valley, and the prevailing winds carried it throughout New England, and it was causing vast destruction there. And so in 1980, the Congress authorized a 10-year study, the most thorough ever conducted, of acid rain and its consequences. It is called the National Acid Precipitation Assessment Program, NAPAP. It took 10 years. It employed more than 750 of the finest scientists in the country, and as I say, it was the most thorough study of acid rain ever conducted. It cost you about $600 million to conduct this. The study was completed by 1990, during which year the Congress considered amendments to the Clean Air Act. Although this study, as I say, had been completed, it was withheld by the Environmental Protection Agency until the congressional session was over, and none of the congressmen seemed to remember that they'd asked for this study, so it was not taken into consideration. The result being that the Clean Air Act amendments call for something like $4 billion to be spent correcting acid rain, controlling emissions that might cause it, whereas the study showed clearly that not only were the charges against about acid rain vastly exaggerated, that the amount of damage was very minimal. It was a bit of a problem in a few places, but for the most part, less than 1% of all the waters of New England, the lakes, rivers, streams, and so on, and any other affected place, had not been acidified, and the only forest area that was adversely affected is a small area of red spruce in New York State. That these problems could be corrected by using lime to add to the waters or to the land, and the total cost would be about $100 million a year. So we're spending $4 billion to correct a $100 million problem. Indeed, one of the things that was not made public from the report was the astonishing finding that far from doing damage, the sulfates and the nitrates in the so-called acid rain were adding nutrients to the very poor soil of the New England states. The New England states have a rocky soil which is based upon granite. It has very, very few nutrients in it, and plants need nutrients to grow. Among those, among the most important, include sulfates and nitrates, and a few other things like phosphate and calcium and so on. The very things that were being deposited in New England by the acid rain. The result is that although New England was clear-cut a number of years ago, it is now almost completely reforested in the places where the forest can grow. In fact, the state of Maine is the most densely forested of any state in the Union. 90% of the area of Maine is covered by trees, and these forests of New England are among the most vigorously growing of any forests in the United States because they receive their annual amounts of nutrients from acid rain. Indeed, this acid rain is now called, in some places, poor man's fertilizer. The same result has been found in Scandinavia, the forests of Sweden, Norway, and so on. This is an example of the problems that we get into when we demand action to be taken before the scientific information is fully available. Well, we're told that these controls down to parts per billion of things like ozone and carbon monoxide and other materials in the atmosphere must be controlled because of their effects upon public health. Well, certainly it is true that those substances in reasonable amounts or in too large amounts can have adverse health effects. But at what level? There is an old philosophy that comes out of pharmacology which holds that the dose makes the poison. Some things can be very beneficial in low concentrations and yet fatal if you have too much of it. One of those things is oxygen. Oxygen, in fact, is a very strong carcinogen, and in too great an amount, at too heavy a concentration, oxygen can give rise to cancer, and it can cause a fatality. Should we ban oxygen, therefore? Because I think most people will admit that a certain amount of it, like about 20% in the atmosphere, is a good thing to have. Moreover, if there were really severe health effects from the ambient amounts of these various things in the air, there surely would be some evidence of it. And if we go to look for evidence of a public health effect, the place to look, of course, is the Los Angeles Valley. Because in Los Angeles, it is well known that the smogs are the worst. The amount of air pollution, the urban air pollution, is the greatest. It comes as a surprise to a lot of people to realize that Los Angeles, indeed the whole area there, has no greater amount of respiratory problems in the population than any other city in the United States. In fact, it's a little more healthy than most. It is true that if a person has an already existing respiratory problem, like asthma, for example, then little small amounts of ozone in the atmosphere can irritate it. But for people that don't have respiratory problems caused by something else, there is no evidence whatsoever that the constituents of urban smog are a public health problem, but cities are being made to go to extraordinary, expensive lengths in order to cure something that really isn't a problem. Not that we want dirty air, but remember, we've cleaned up 90% of it. Let's turn for a moment to clean water. We've just had a new clean water bill passed, and wait till you see the bill. I'll just give you 3 examples of some of the consequences. The Clean Water Act amendments require that municipalities have to remove at least 30% of organic material from effluents before adding them to a natural body of water. I said that very delicately. That means the sewage that goes into water eventually has to have 80% of the organic material removed. Now, the city of Anchorage, Alaska, has a problem with this because there is so much rain, well, maybe not as much as in the Mississippi Valley, but there is so much rain usually in and around Anchorage that their waters are so highly diluted, even though their municipal waste goes right into it, you cannot detect any organic material. So they applied to the Environmental Protection Agency for a variance. No, said EPA, the law is the law. You have to take 30% of the organic material out. So what was Anchorage to do? It did what a reasonable, ingenious American would do. The city made an arrangement with 3 different fish processing companies, requiring the fish processing companies to dump all of their fish guts and cleaning and offal and so on into the municipal waste system, and then they could take 30% of that out. Made EPA real happy. Then there is the state of Maine. The requirements of the Clean Water Act will cause the state of Maine to have to pay annually $1.5 billion. Their entire revenue from property taxes amounts to only $750 million. They're in discussion and have been for months with EPA as to how to resolve that problem. Let's take the city of Columbus, Ohio. There is a substance which is used sparingly in farming called atrazine. It is a pesticide, very useful, and the EPA controls it to the point where there may not be more than 2 parts per billion of the material to be detected in waters. Well, Columbus, Ohio, had a test, and they had 3 parts per billion, difference of 1 part per billion. They are being required to spend about $15 million to build a plant to remove that extra 1 part per billion from the water, when it is known, and EPA knows this too, that for any health effect to be detected whatsoever, the concentration of